Okay, what if we could value everything? And I mean everything, from a single human thought to the entire output of a company, using one universal currency. Not dollars, not yen, but energy itself. Today, we're diving into a framework that completely redefines value at its most fundamental level. We're going to measure intelligence and action in the only currency that truly matters in the physical world.
Take a look at this number. 100 gigawatt hours. That's not a city's power bill anymore. In the world of AI, this is the new language of business. I'm serious. Major deals are being signed not for cash, but for guaranteed access to this much computational energy. It's the new price of progress.
And that, right there, brings us to the core of this whole explainer. We can put an energy price tag on a machine's output, sure, but how do we stack up? You know, when we actually measure the value of a human brain against the silicon brains we're building, well, we find ourselves at a pretty remarkable and maybe temporary tipping point.
To figure this all out, we've got to start small, like really, really small. We're going to zoom all the way down to the level of physics and biology to find the smallest possible unit of a single purposeful action.
This slide really shows you the sheer scale of energy at play. I mean, way down here at the bottom, you've got the absolute theoretical limit set by physics. The cost of an action is almost nothing. A tiny step up from that is the practical thermodynamic limit, basically the rock-bottom energy cost to erase one bit of info. But here's the jump. Biology, with its little ATP energy packet, operates with unbelievable efficiency, just right above that physical floor. And then there's our best technology, all the way up here.
So let's put that side by side. Our most advanced transistors, right? The building blocks of every single computer need about 60 electron volts to do one thing. Nature, on the other hand, powers every fundamental action in your body, a neuron firing, a muscle contracting, with an energy packet that costs just 0.3 electron volts. That is a 200-fold difference in efficiency. It's incredible. For billions of years, life has perfected this art of operating just above the noisy chaos of thermodynamics. It really gives you a hint at why bio-inspired computing is such a huge goal, right? Our best engineering, it can't even touch nature's blueprint yet. So to make any sense of this, we need a standard yardstick. And inspired by the energy a single photon delivers during photosynthesis, we're going to set our quantum of intent at a nice, round 1 electron volt. This is going to be our building block for comparing all kinds of intelligence. All right, so we have our yardstick, the 1 electron volt quantum of intent. Now, let's use it to scale things up and make a comparison that is truly mind-bending. The energy cost of a single human thought versus one AI-generated word.
So, how much energy does a single human thought actually cost? Well, if you take the brain's total power consumption, which is about 20 watts, and you estimate how many distinct impressions or tokens it's processing every second, the math leads you to this just staggering number, roughly 10 to the power of 18 electron volts.
And now for the kicker. What's the energy cost for a modern, efficient AI model to generate a single word? Well, what do you know? It's in the exact same ballpark, 10 to the power of 18 electron volts. The orders of magnitude are practically identical. It's wild. This is what the source calls energy parity. Now, let's be super clear here. We're not comparing apples to apples. A human thought is this deeply complex, associative, multi-layered thing, right? An AI-generated word is a probabilistic, statistical output. But the fact that they consume the same amount of energy to be produced, that is a genuine landmark moment.
To make this a little less abstract, think about it this way. The energy needed for an AI to generate just half a page of text is the physical equivalent of you lifting a 1-kilogram bag of sugar from the floor up to your stomach. This isn't just some trivial digital dust, it's real, physical work being done.
But here's the catch, and it's a really big one. This moment of parity is, as the source puts it, a fleeting moment. It's just a snapshot in time, it's not the final destination. And that's because the two systems, well, they're on fundamentally different tracks. So that fleeting moment of parity, it brings us to the next crucial part of this story, the Great Divergence. This is the race between a biological system that has, for all intents and purposes, already peaked in its efficiency, and a technological one that is really just getting started.
I mean, this chart says it all, doesn't it? The human brain is an evolutionary marvel, no doubt, but its hardware is essentially fixed. It's a static peak. AI, on the other hand, is on an exponential curve. Every single year, our chips get faster, more efficient. The algorithms get smarter. That energy parity we just saw, it's not just going to disappear. It's about to get left in the dust.
This accelerating efficiency gap isn't just some technical curiosity, It has profound, real-world economic consequences. So we need to zoom back out and really understand what this means for how we value, well, everything in our economy. So here's the fundamental economic problem, this energy gap. AI runs on electricity, measured in kilowatt hours. We humans run on food, measured in kilocalories. And when you compare the cost of a joule of energy from the power grid to a joule of energy from a decent meal, the difference is just staggering. AI labor is powered by a vastly cheaper fuel source.
So, if the raw cost of energy is becoming the deciding factor, how do we measure a company's true value and sophistication? The source proposes this new metric, joules per unit of output. It's simple, really. The less energy a company spends to create its product or service, the more advanced and valuable it is, fundamentally.
Just take a classic example, like Adam Smith's pin factory. Company B is using old tech, and it spends 160 joules for every pin it makes. Company A invests in some new machinery and gets that cost down to 145 joules per pin. Boom, Company A is the winner. This exact same logic applies to everything, not just a data center or a car factory, but to any business. The ultimate winner is going to be the one that uses intent most efficiently.
And this relentless, unstoppable drive for energy efficiency leads us to the final and maybe the most important question of all. If machines become better and cheaper at doing everything, what is left for us humans to be?
The path seems to be leading here. First, raw labor, both cognitive and physical, just becomes too expensive compared to the automated version. Then, value shifts away from doing the work to defining the work. The primary human contribution becomes setting goals, defining purpose, and validating the outcomes. We become the creators and, I guess, the arbiters of intent. And so we end here, with the central challenge of this whole new energy framework. In a world where machines provide the cheapest and most efficient labor there is, what makes us uniquely valuable? And that's not just an economic question, is it? It's the defining philosophical question of our century.